But I see your point, but physicists could ask the same question, mathematicians could ask the same question. I suppose chemists too, but I had to follow. But biologists don't ask this question. And I think that's just because the number of unsolved problems in biology has always been way orders of magnitude more. That there's just so much to know that questions lead to new questions that are unexplored much faster. And I have to, so I have to say that I can confidently predict that biologists will have great stuff to work on 500 years from now if we don't blow civilizations apart. But I can't, and I can confidently predict computer science will have good stuff to work on 50 years from now. But now look at it also this way. There are a lot of people who spend their life studying Dante or Chaucer or something, and you might say, well, maybe all of the interesting questions about Dante have already been explored, but they don't seem to think so. My main worry for computer science, however, is not that what you say, but it's just that I'm not sure if I would want my son or daughter to go into a career now where all they're going to be doing is going to be using libraries, plugging in magic incantations into systems that somebody else has written, and they have to somehow just say, well, how am I going to apply which method to this? That's pretty boring. And how am I going to make that fun and creative and exciting? We got this idea that we should have open software, and to me that means you have to have 10 books open at once in order to see whether you're supposed to write the parameters in this order or the other. So it's not at all the kind of software where you're sort of harnessing the machine to do something at the limit, but you're more or less just doing some routine things because you happen to be fairly good at dotting I's and crossing T's. So there's a challenge now to take these tools that we have and give control back to the people who are using them instead of having the tools. But I don't know how to express myself too well, but it's something like this. There was a student here of mathematics, and a lot of people think that the purpose of mathematicians is to prove theorems. You want to prove that pi r squared is the area of a circle or something like this. And then you tell people what the theorems are, and then they pay you so much for so many theorems or whatever. You can't patent theorems, but it's something like people think that a mathematician's job is to spew out these theorems. But in fact, all mathematicians know that the theorems almost never match exactly the problem that you're trying to solve. They're close to it. The theorem always says, if such and such is true, and such and such is true, then such and such is true. And the premise of the theorem is it's usually almost right, but not quite there. So what you need to do is not have the theorem, but you have to have the proof. You have to see how they proved the thing instead of the statement of the theorem and the answer. You've got to see the method. You've got to see how they did it, because you've got to tweak that to your problem, which is slightly different. Okay, so now it's the same thing in software. People want to package their thing. They got an algorithm to do such and such a thing, and they put a few things on the menu. Yes, I can extend it this way, this way, this way. But they don't allow you to open the box and see what's inside, and they don't say how you can treat the method to change to another product. And people have made a religion about this. They say this is the best thing, the best possible thing you want to have something where you try to have information hiding and all this stuff, and you put things together on a high level, and you never allow looking under the covers. And it's easy to see that this is inefficient. A lot of cases, for example, if you have you work with matrices and you want to do arithmetic with complex numbers, instead, if that means you have to have twice as many matrices, you have to multiply the total amount of work by 4. But if you're allowed to open up and redo your calculation so that you know you're working with complex numbers, it only takes you 3 times as long. But we're not allowed to do this. We're not allowed to change somebody else's code if you have this idea of all subroutines have to be reusable rather than re-editable. And that leads to more and more complicated interfaces and less fun. So I like the idea of having always a chance to customize stuff. And we'll see what happens in the future. Question over here.
If you were just starting out today as an undergraduate, what do you think you'd like to work on?
I work?
If you're just starting out today as an undergraduate, what do you think you'd like to work on?
Yeah, what would I like to work on if I were starting today? Other than biology. No, I'm just kidding. And you mean in the computer field, right? Yeah. So I think that really it depends on the person, but I would just I would, if I was any good at computers, I would almost see too many things that I'd like to work on. When I go to, if I go to the doctor or wherever, I could see that something could be done better. Because for a long time there's going to be programming is a rare talent. About 2% of the population of the world has this peculiar way of looking at things that make them really good at programming. If you've got that, then you see, then you've got to be in demand because there aren't that many people who can do it. And there are so many things that haven't been done right yet. And I mean, it's I mean, here at Case, you've got the big connection with the hospitals and all the clinics going on. There's so many applications to medicine that are just calling out to have some good algorithms. But then you look at graphics and you see, you go to the movies and you see all kinds of really cool stuff that you can do with making video displays. I get excited about the way patterns work together, like the man asked me about Fibonacci numbers. You know, and I found beautiful patterns that are coming out of these things and things that just hang together in a very artistic way, and it gives me sort of, my left brain and right brain are both happy at the same time. So I'm using the science of patterns to create beautiful patterns. So there's great advances in photography now that all kinds of things that haven't been built into cameras that people can buy that are being known about. Now, when we have the digital processing of all this information, we can do. Cameras can get around all the limitations of optics from the pattern.